Hi everybody, Miss Rose here. This video is going to help you with week 3 homework 2 that's in the Google Drive folder. We've been focusing on talking about lines, rays, and segments today. Right now we're going to focus on the word congruent. Congruent means when two things are the same size and same shape. Well, think about a line. It goes on forever in both directions. You can't have two lines that are congruent to each other because they're infinitely long. Same with rays, but you can have two segments that are congruent to each other. So here's a segment, I'll call it AB, and then here's another segment, I'll call it JK. If those two segments had the same length, then they would be congruent. And the way that you mark that is you can put matching tick marks on it. You could go with double ticks, you could go with any marking as long as they match. So we're going to be applying what it means for segments to be congruent to some problems that involve some algebra. So let's take a look at this one. This is the symbol that means congruent. So I talked about same size and same shape. The squiggle means same shape, and then the equal sign means same size. So whenever you see that symbol, it means congruent, or in the case of segments, it means that they have the same length. So I'm going to mark with a tick mark that segment AB is congruent to segment CD. And sometimes it's good to put all of these expressions on the picture too. So AB is 7x minus 5, BC is 8x plus 9, and CD is 5x plus 1. Sometimes we get into the habit of thinking that we need to use every single detail in a problem in order to solve an equation. But in this case, I just want to use the two segments that are congruent to each other and take those expressions and set those equal to each other. So that's what I'm going to do. Segment AB is congruent to segment CD, so their expressions can be set equal to each other. And then I just solved this just like I solved equations in algebra last year. I'm going to subtract 5x from both sides of the equation. Some of you like to draw a line to keep the two sides of your equation straight. 2x minus 5 equals 1. So now I'm going to add 5 to both sides. 2x equals 6. And then don't forget that the last step is you divide. So x equals 3. A lot of times people celebrate, yay, I'm done, I did a good job solving. But you're actually not done until you finish answering the question, which in the case of this class, a lot of times won't just be find x. So what we're going to do is we're going to take x and we're going to plug it back into all these expressions and figure out how long all of these segments are. So 7 times 3 is 21. 21 minus 5 is 16. 8 times 3 is 24. 24 plus 9 is 33. And then 5 times 3 is 15, plus 1 is 16. Phew, we wanted A, B, and CD to have equal lengths because they're congruent to each other. And then AD is how long is the whole thing all together. You might notice that I didn't put a segment bar on there. It's because when you're dealing with length, you actually don't use a segment bar. So AD is all three of those segments put together, which I believe gives a total of 65. So that is an example of an algebra problem using congruent segments. Often, once we start studying this, people start thinking that segments are congruent in every example and that they always should set expressions equal to each other. So I want to do a little bit of comparing and contrasting. So you might notice that the first thing that I'm doing for this problem is labeling the given information on the diagram. This time, though, it does not say anywhere that those segments are congruent, so I'm not going to put any tick marks. So you might wonder how you're going to set up an equation. Well, it gives me one more piece of information. It gives me a total for AC, 41. So we don't know that two things are equal. We just know what something is for the total length of both of those segments put together. So what I'm going to do is I'm going to add the two segments up this time. So when two things are congruent to each other, you can set them equal to each other. When you know a total length, you can add things up. I'm going to combine like terms because they're on the same side of the equal sign. So 1x plus 3x is 4x. And then 7 minus 2, or 7 plus negative 2, is 5. Positive 5, so I put plus 5. And then equals 41. And then I can solve that quick equation by subtracting 5 from both sides and dividing by 4. I get x is 9. And again, we can't celebrate too fast. We're not done. We have to plug that in and answer the question. So I'm going to plug 9 in for x. 9 plus 7 is 16. And then I'm going to plug 9 in for x for the other segment also. 3 times 9 is 27. 27 minus 2 is 25. The good news is that they do add up to 41, which is what we were given. The bad news is that they are not equal to each other. So no, AB is not congruent to BC. Their lengths are not the same. All right, here's one more example. Instead of algebra, this one's just going to be an arithmetic problem dealing with lengths of segments, but there's a lot of given pieces of information and it can be really tricky to label this all on a diagram. So PR is 42. What I don't want to do is just stick a 42 in the middle of the diagram somewhere because you're going to think it belongs to something else. So I like putting some sort of bracket to show that the whole PR is 42. Then just the PQ part is 34. So I can already see something clever that I can do here when I want to see what's left over. If the whole PR was 42, and then just this little part here is 34, I can subtract and see what's left over. So 42 minus 34 is 8, and that's what's left over for QR. QR is 8. All right, I'm going to look at what's given. What's given is RS is 8. So is QR congruent to RS? Are they congruent to each other? There's my little markings. And the answer is yes, because they have the same length. Yes. So I'm going to say the length of QR equals the length of RS, which equals 8. So when I'm talking about the segments, I use this segment bar, but when I'm talking about the length, I don't put a segment bar on it. Just a little picky detail that I wanted to share. So that sums up segments. We're going to do algebra and arithmetic problems dealing with segment lengths and segments that are congruent to each other. And now you can go in Google Classroom and practice week 3 homework 2. See you later.